Okay, section 2.4, we are solving multi-step inequalities. So by the end of this lesson, you will be able to solve multi-step inequalities. Really, in this section, what we're doing is we're taking all of our previous knowledge from sections 2.1 to 2.3 and putting them together to solve multi-step. So there really isn't anything new in this section. Okay, we're just kind of putting a bunch of our old stuff all together. So one thing, word of caution. So here's our caution right here. The most common mistakes when solving inequalities is, first of all, forgetting the multiply or divide by a negative. Remember, if you multiply or divide both sides of an inequality by a negative, okay, you must switch the direction of the inequality. Okay, so that's a very common mistake. Again, multiply, it's just for multiply or dividing both sides by a negative. Okay, you have to switch the direction of the inequality. That was from last section. Okay, another really common error is switching the side of the variable. So if you switch the side of a variable, for example, if I have 6 is less than x, but if I want x to be on the other side, I have to switch the direction of our inequality. Okay, so we can't forget that bit as well. And really, again, to undo, you have to undo in the backwards order. Okay, that's also another very common mistake just in solving multi-step equations in general. Okay, what I mean by that is here in this very first example is to solve each inequality, graph the solution. So here we want to solve this guy for y. Right now y is being divided by this -6 and then adding 7. To undo these things, I need to undo the divide by -6 and I need to undo the add 7, but to undo, I have to undo in reverse order. So I'd have to undo the subtract first. So I'm going to have to, that add first. So I'm going to have to subtract 7 from both sides first. So if I subtract 7 from this side, this add 7 subtract 7 is 0. So I'm left with a y divided by -6 is less than 9 subtract 7 is 2. Okay. And so I got rid of my add. So now I need to undo this divide by -6. So to undo a divide by -6, I need to multiply both sides by -6. And put them in parentheses so we know we're not subtracting. But again, that's my very first caution. Here I am multiplying both sides by the negative. So the direction of my inequality has to switch. It has to go that way. Okay, so then this multiply by -6, divide by -6 is 1. So y is going to be greater than -12. Okay, so now I'm going to go ahead and it says to graph it. So here's 0, here's -12. So we're going to have an open dot at -12 and we want greater than -12, so we're going to have to go this direction. Okay, and then it's always a good idea to check your work. So I'm going to pick a number up here. I don't know, let's pick the number 6. Just because it'll work out nice up there. And then let's check it. So over here's my check. So if I put a 6 in here, we'll have 6 divided by -6 plus 7. Is that less than 9? 6 divided by -6 is -1 plus 7. Yep, that would give me 6 less than 9. It worked. So there is my solution. Okay, next one. So we have 2v minus 4, okay, is greater than or equal to 8. So again, I will need to, so we're solving for v. So we have 2 times, that's a multiply, times v, subtract 4. So first thing I have to undo the subtract 4. So to undo a subtract 4, I'm going to need to add 4 to both sides. So this subtract 4, add 4 are opposite signs, so they add to 0. So 2v is going to be greater than or equal to 12. Now I'd undo the multiply by dividing both sides by 2. V is greater than or equal to 6. Here I'm dividing by a +2, so I don't need to worry about switching the direction of my inequality. We want to graph this guy. Here's 0, here's 6. We're greater than or equal to, so we're going to need a solid dot, and we want greater than 6, so we're up here. Again, let's try a number up here, make sure it worked. I don't know, 10? Let's switch it. Okay, so let's put 2 times 10 minus 4. Is that greater than or equal to 8? 20 minus 4. Yep, it does work. So there is my solution. Any number greater than or equal to 6. Okay, next. Oh no. Oh, thought my iPad froze up. Okay, here we're going to solve this inequality. This one, again, we're solving for x, has two x's. I've got an x in this term and an x in that term. So I need to get all my x's to one side. Okay, so I think I'm going to subtract this one over to that side. So we're going to subtract that 2x from both sides. So these two together get me 0. On this side, 6 minus 2x is 4x minus 5 less than 11. Now we would need to move that 5, so we're going to add 5 to both sides. Please don't do those all in one step. It tends to confuse the problem. So we have 4x is less than 16. And then get rid of the multiply by 4 by dividing both sides by 4. X is going to be 16 divided by 4 is 4. X is less than 4. So let's go ahead and let's graph this. Here's 0. Here's 4. This is strictly a less than, so we're going to have an open dot here. And then we want less than, which is this direction. Okay. So always a good idea, check. Let's go ahead and let's pick a number over here. I don't know, the number 2 is over there. So let's check it. Make sure it worked. So we're going to do that too. So we'll have 6 times 2 minus 5 is less than 2 times 2 plus 11. So we're checking, did that work? 6 times 2 is 12. Minus 5. 12 minus 5 is 7. And then 2 times 2 is 4 plus 11. That's 15. Is it less than? Yep, it worked. So we know that that's a valid solution. All right, next. Okay, we have 8b minus 3 is greater than 4 times 2b plus 3. So again, we have two b's. We have one there. We have one there. I have a 4 times this quantity. So I think first step here is going to distribute. Let's distribute that in. Okay, so we'll still have an 8b minus 3 here is greater than 4 times 2 is 8b plus 3. Okay, so again, I have a b here and a b here. So I'm going to subtract 8b from both sides. But 8b minus 8b here is 0. So this side, I'm just left with a negative 3. It's greater than. On this side, 8b minus 8b is also 0. So this side, I have a positive 3. Well, look at that. I don't have any variables. My variables added out. Okay, that's okay. If you remember from a previous section back in chapter 1, if that happens, we look to see, is the resulting sentence true or false? Is negative 3 greater than 3? Not last I checked. So no, this is a false statement. Since this is a false statement, that tells me that there is no number b. I can't put anything in here to make this guy work. There's no way this side could ever be bigger than this one. So for my solution here, I would write no solution. I can't just write false. I have to write, because it says here, the directions say to solve this. Okay, so I will need to write no solution. Okay. All right. Very last example here. Okay, so this one looks very similar to the last one, and then we've got a w on both sides and a distributive here. So let's go ahead and let's distribute this 2 in, because it's 2 times that quantity. 2 times 5 is 10w minus 2. 7 plus 10w. Okay, like the last one, I'm going to take this 10w and I'm going to subtract it over to this side. So let's subtract 10w. Subtract 10w. And very similar to the last one, this gives me 0. So on my left side, I'm left with a negative 2. Less than or equal to. And on my right side, that is also 0. So I'm left with a 7. But unlike the last problem, what remains here, negative 2 is less than 7, is a true statement. This right here is true, which tells me no matter what number I pick, any number in the whole entire world, when I put it in here for w, for both sides, this side will, the left side will always be smaller than the right side, no matter what number I pick. So this tells me that any number will work. So we'd say any real number. Okay, or even better, we say all the real numbers work. So instead of using any, we would say all real numbers will work. So if I was to graph this, okay, well, 0 works. Well, so does 1 and 2, and any number up here will work, and any number down here will work. So really, my whole entire number line is shaded. So all my real numbers will work. Okay, whereas here on this last one for part A, if I was to graph this one, well, 0 doesn't work, and neither would 1 work, and neither would none of these numbers will work, so I wouldn't shade anything. It would just be a blank number line with nothing shaded, because that has no solution, unlike this one has all the solutions. Any number works. I could come up here and pick the number 100, and if I put a 100 in there, it'll work. Negative 52, that one will work too. Any number will work. Okay, so please let me know if you have any questions, and come see me if you need help with your practice.